Hi guys, just a quick lesson on relations and functions and their differences. So our aim is to understand and draw and determine if a relation is a function. So a relation is a set of ordered pairs, and you can see this ordered pairs on any graph, okay? And the domain is the x coordinates, and the range is the y coordinates, okay? So domain is your x, and range is your y. When writing the domain and range, do not repeat any values. So if 3 is in the range twice, you only need to put it in the once. So for this example, given the relationship 2, -6, 1, 4, 2, 4, 0, 0, 1, -6, 3, 0, I'm going to state the domain. So again, the domain is my x values. So my x values are 2, 1, 2, 0, 1, 3. So I'm going to just write them and remember not to repeat any. So I've got 0, 1, 2, and 3. So I write them as a set with commas between them. My range, I've actually printed this, so I'll just do that. So it's 0, 1, 2, and 3. Write them as a set with curly brackets. And then the range is going to be, again, need to remember, -6, 4, 4, 0, -6, 0. So again, I don't want to repeat any. So I just have my -6, 0, and my 4. And always write them in numerical order. Okay? So relations can be written in several ways. Ordered pairs, which we've just done, we can see them in a table next, a graph, and mapping. So mapping is the two ovals mapping onto each other. We have already seen relations represented as ordered pairs, So this table here, we've got our x values and our y values. So obviously you can write any table of values as ordered pairs, so that's just them there as ordered pairs. The 3 is the x, the 4 is the y, etc. And you could list the domain and the range from there if you wanted to. So my domain is that x is equal to, again, don't repeat any, so I've got my smallest is -5, so I want them in numerical order, -2, 3, I forgot 0, sorry, -2, 0, 3, and 7, and that's that one. And then my range, again, don't repeat any, so I should have y is equal to -1 is my smallest, then 0, 2, 3, 4, and curly brackets. Okay. So when you're mapping, you create two ovals with the domain on the left and the range on the right, and elements don't repeat. So remember that your elements don't repeat. You can have repeating arrows going from the same element, but don't repeat the elements in the ovals. Connect elements of the domain with the corresponding elements using arrows. Okay. So again, I've got my 2 and my 6, so I'm using an arrow to connect my 2 to my 6. Then I've got 1 and 4, so it's going, 2 and -6, so then I've got my 1 and my 4, so that's going across to my 4. My 2 and my 4 is also joining with an arrow. My 0 joined with an arrow. 1 and -6 joined with an arrow, and my 3 and my 0 joined with an arrow. Okay, so that's a relation being mapped with the two ovals. A function is a relation in which the members of the domain x values do not repeat. So it's really important that your x values do not repeat. Okay, so for every x value there is only one y value. The y value has to be unique. Okay, and y values can be repeated, but x values can't. Okay, so your x values can't be repeated, but your y values can be repeated. That's what makes it a function. So we have different types of functions. A discrete function consists of points that are not connected. So when you're using your natural or your integers, you're counting numbers. So it's not including all the fractions and decimals. Continuous functions can be graphed with a line or smooth curve and contain an infinite number of points. So infinite again. And the discontinuous functions have a break in a line of its graph. So if I was talking about maybe my rectangular hyperbola graph, so they have an asymptote, so that's where it's discontinued. Okay. So do the ordered pairs represent a function? So in order to work out if they represent a function, we have to check that their x values are not repeated. So I've got a 3, a 7, a 0, a -2, a -5, and a 3. So my 3 is repeated, so therefore it's not a function. Okay, because the 3 is repeated in the domain. The next one is 4, 5, 8, 9, so my x's aren't repeated, so that is a function. Okay. So with the graphs of a function, you can check for your vertical line test. So if a vertical line is passed over the graph and it intersects the graph at exactly one point, the graph represents a function. So we're going to look at that now. So does this graph represent a function? So if I was to draw a vertical line for this one anywhere along this graph, it's only going to have one intersection, which means it is a function. So yes, it is a function. My domain is going to be, it's infinite because it's got the arrows going on the end, so my x's go from left to right anyway at all. So it's an element of real numbers, so my domain when x is an element of real numbers, and it's the same for my y because it's a linear graph, so it's going up and down to infinity and to negative infinity. So yes, the range is an element of real numbers. Okay, so on this graph here, it's the absolute value graph. I'm going to try my vertical line test. So if I did my vertical line test, it passes that. It only has one intersection. So again, it is a function. And the domain is, again, for x can go as far left as it can right. So it is an element of real numbers. And my range has a little bit of a restriction on it because this is the minimum point. It's never going to go lower than that, and that minimum point is 1, 2, 3, 4, 5, 6 below the 0. So my range is anything greater than or equal to negative 6. Okay. Does the graph represent a function? Name the domain and range. So again, same thing. It's a graph this time, so I can use my vertical test. It's not going to pass my vertical test because it has two intersections, which means that any x value has two y values. So that means it's not a function. Okay, so it's not a function, and our domain is going to be limited because the x value, the minimum value, is at this point here. So that's going to be x is greater than or equal to a half. Okay, so it's anything greater than or equal to a half. So that picture is supposed to be on the half mark. Okay, and my y values are infinite, so they can go as far up and as far down. Okay, so into the positive infinity and down to the negative infinity. Okay, so it's an element of real. Again, my next one isn't going to pass my vertical test. It's going to have more than one solution, so I can say that it's not a function, but the domain is an element of real and the range is also an element of real. Continuous. So for this example here, we want to see if it is a function, so name the domain and the range. So again, in order for it to be a function, it has to pass the vertical line test. So I can draw this graph maybe on a CAS calculator or just draw it myself, and I will work out that my y is equal to the square root of x minus 4 is a function. Okay, so it is a function, and I'm going to look at the range and the domain. Okay, so the domain has to be, so our domain has to be greater than 4. Sorry, greater than or equal to 4. If it was anything less than 4, then my number inside my square root would be negative, so I wouldn't have a solution for that. Okay, so my domain has to be when x is greater than or equal to 4. Okay, in order for the square root to be positive. And then my range is going to be y when y is greater than or equal to 0. And I have to close my bracket, so again I want my y's to be positive, otherwise it wouldn't be a function. Okay. So for the next one then, I'm looking at y is equal to 1 over x plus 2. So again, this is a rectangular hyperbola. So this function here is a rectangular hyperbola. So it is a function, but it's going to discontinue at some point. So because we've got a rectangular hyperbola, so we have to allow for the asymptotes. So if my x was equal to negative 2, sorry, I'll just do that with a different colour pen. If my x was equal to negative 2, then I would be dividing by 0, and that won't work because that's undefined. So my domain, can never have a value of minus 2. So I will say that my x is an element of all the real numbers except negative 2. sorry, excuse my curly brackets, and then my range is an element of all the real numbers, but it'll never be 0, because because anything 1 divided by any number can never give you 0. Okay, so we'll have to exclude the 0, and this is how we write it with the curly brackets. Okay, perfect. So function notation, when we know that a relation is a function, the y in the equation can be replaced with f of x, therefore it's a function, and f of x is simply a notation to designate a function, and it is pronounced f of x. The f names the function, and the x tells you the variable that's being used, the independent variable. Okay, and that's it, we're done.